gentlemen, welcome to the big depression, to the big biological depression of the land. So I would wonder if some of you will sleep, so I can excuse it because we are all of biological origins. The second is, some of you maybe wonder why there's evolution in relation to practical application. One reason is that we cannot understand and we cannot find real or applicable solutions if we don't consider processes which are govern our environment, and we have to check our paradigms which we are using already, and on the other hand, it's necessary to understand how people work within the society. You mentioned some biological phenomena which are based on evolutionary processes, and I will try to explain some relations. So, what are basic principles of evolution? There is the situation that we have two different hierarchies. One is the energetic hierarchy based on abiotic processes, which governs also the biotic processes, and we have the situation of self-organization, which is within organisms, and the counter-working hierarchy, but both hierarchies are interesting because I will explain that each life needs energy, and energy by organism is only used by a small part of the whole energy which is available. Approximately 0.1% of the energy. Other forms of energy are also used only indirectly by organisms, for example, the distribution of heat and also for passive movement, but there's also the risk that organisms will be destroyed by high energy impact, avalanche and so on. So the classical view, or not the classical, the current view of evolution, which is dominantly focused on genetic germline, has to be extended to energy on one hand, because of input to organisms, which organisms are storing energy and also material within the body to survive situations where no energy is available. They will lose heat, they will lose respiration, and they will also lose biomass or also their life, because they're at the same time also resources of energy. And all organisms need information processes to be oriented on one hand where resources are available, and on the other hand to avoid losses which are not desired. So, what are the basic characteristics of all organisms? They are non-linear, dependent on physical and chemical environmental factors within relatively narrow units in comparison to physical dimensions. They have limited capacities for energy transformation. They have limited capacities for material transformation. And they have also, this is also valid for all organisms, including ourselves, limited capacities for information perception and processing, because all organisms are adapted to manage and to operate within local conditions and with relevant information. And all organisms have the inherent tendency to overproduction because they have to compensate unpredictable losses. The main sources of primary energy for organisms are, on one hand, chemical one, the so-called chemoautotrophic energy chain. On the other, much more prominent, is the photoautotrophic, which is based on the sunlight. What are the differences? Chemical energy is dominantly available in geochemical sources with some spatial distribution and with discontinuous operation. You can see here the known peaks and hydrothermal vents which are distributed over Earth, which are operating for short term in relation to biological situation. And if you compare it to the solar situation, where you have here the latitudes, and you have annual cycles which are very prominent in higher latitudes, lower in the equator, and with different situations, but it is ubiquitous, available over the Earth. What are the basic differences between processes? In chemotrophic cases, we have the situation that the flow of materials and energy are more or less in parallel. They are discontinuous, and in spatial heterogeneous sources, we have on one hand a high diversity of different energy sources and also a high diversity of metabolism. But to use this energy needs an adaptation to a large bandwidth of abiotic conditions, maybe temperature, pH, and so on, and the possibility to survive long starvation periods. So this one is dominantly or only used by unicellular organisms. In comparison, the phototrophic processes have the situation that the energy flow is more relatively independent of the energy flow, of the material flow, excuse me, and so they can much more recycle material and rule much more the material, and it enables the development of multicellular organisms. The energy availability depends on latitudinal conditions, in the sea it depends on the depth, and it limits the primary metabolic diversity, but it increases the phenotypic and structural diversity. We will discuss this point a little bit later. But what you can see here, that both principles existed after the appearance over the whole time, but you can also see here that there were heavy feedbacks to the atmosphere, the oxygen concentration, which is based on the phototrophic processes, which started the model of fixed bandwidth, and we have also the position of so-called banded iron, which based on the biological processes. So we have, on one hand, the continuous flow of kinetic germline over the time, which is realized by individuals which have to survive with the biotic interaction and also interaction with abiotic conditions. So each individual have to survive the test and to reproduce over the time. Hopefully it's not an alcohol. And if you look at the system level, so each organism which evolves or starts to evolve has to put a place on an occupied table, because the sea organism existing, in particular microorganisms existing all over the world, and they have to find a place and to have an agreement with interactions with other organisms. If they cannot agree, so they will die out, or if they are too successful, other organisms will die out, and if you have a very imbalanced situation, a big mass extinction can occur. To understand what iteration cycles mean, we have, for example, a situation what tropical forest where you have a continuous flow of energy, the continuous availability of water, where the huge number of iteration cycles provides a high biodiversity with strong specific interspecific interactions and constraints also. And on the other hand, we have the phenomenon, which is very surprising for people from our region, of very shallow soils, because most of the materials reside above ground because of this close interactions among organisms. If you look at in comparison to situations in our region, we have more or less interruption every year of this iteration cycle. The iteration cycles are starting every year new, with the consequence that we have a reduced biodiversity with variable interspecific constraints and deep organic soils, because a lot of materials is lost over to the interruptions and is not used by organisms within the system. It's only operated by soil organisms or used by soil organisms over the time. So, what are the basic rules of integration processes? Each organism enters into the integration process at individual scale, so different for a microorganism than elephant. Based on the individual tendency to improve the gains of energy and materials and also to reduce losses. Integration, as I already mentioned, becomes successful if energetic and material flows are kept dynamically in balance for all involved organisms by cooperation, because there are also some non-cooperation, but the number of cooperations has to be bigger that the system will be successful, otherwise it will fail. Integration operates over n-dimensional interaction, not only over one dimension, and long-term integration cycles without any predictable results. And each disturbance or interruption starts a new integration process. We have different examples of integration. One is at the cellular level. We have some cells in the very early history involved or inhaled other organisms and used it as mitochondria, as hydro or energy plants within the cells. But such processes are not always harmonized, because you can see genetically close related to mitochondria are rickettsia. These are endoparasites which are causing, for example, spot fever and so on. So each interaction can result in different ways, and there's no guarantee that a harmonization will operate or will achieve all the time. The other example of integration is the development of multicellular organisms, where a huge number of different functional cells have to integrate in one body and to cooperate within the whole system. And at the ecosystem level, we have small integrated systems with, for example, these microbiotic systems, which are very shallow, only a few millimeters, that will have strong interaction between different organisms, on one hand photoautotrophic and chemoautotrophic, and if we go further, as I mentioned before, we have the structural diversity, which is very important to dissipate energy, which is not beneficial for organisms. For example, if we look at rainforest, the situation, they have very different heights of trees, which is relevant for the dissipation of heat energy in rainforest and so on. So, let's go to the abiotic framework condition. Evolution was not smooth and over the time. We had 5 big extinction events. The most prominent one is the last one, the Cretaceous, where the dinosaurs extincted, but with all the time, the development of evolution of new genera and the extinction of new genera over the time. And this is not only caused by internal interaction, the iteration process, but also caused by external factors. This continental movement, that we know for big homogeneous continents over the time. The movement of geological plates causes also development of mountains and causes also the changes in climate, but over the time also ice ages. So it's not the smooth situation, it's the continuous situation. We have an impression about the change. We will go back to 530 million and you will see that how the plates in our current knowledge move, because these are not satellite photos. I have to mention here because some people are used, okay, there's a picture made by satellite, but this is reconstruction. So, and this movement of continents caused also large changes of continent area, where this big homogeneous continents, 300 approximately 250 million years ago, and at the moment we have relatively small continents. But this was also accompanied by change of sea level up to 600 meters. What we're discussing of 10 meters and so on is relatively small in relation to that was happened in history, but also an increase of sea level since the last ice age of 100 meters approximately. But we have to deal again with events which are not predictable, with the impact of meteorites. The most prominent situation for the extinction of dinosaurs, but the Mexican side is not the responsible one, because there are some time differences, but we have also the influence of eruption of volcanoes. So, the evolution of terrestrial ecosystem provided the framework for the human evolution, but it was also not at the beginning in the same structure as we know, because it started with very small plants, and which were at the height of approximately 20 to 40 centimeters, and then we had an increase of the height up to 30 to 40 meters, and then we have different changes, which I will explain. So, the first ecosystem had only invertebrates, and the energy was dominantly provided by heterotivores. Not by herbivores, but heterotivores. The reasons are complicated, but was also important to consider that each transfer of energy is modified by microorganisms. They are very relevant features. The next step was the increase of the vegetation, but the appearance of vertebrates on land showed only carnivores, not herbivores, and therefore a huge amount of the organic material remained in the soil, which is now the basis for our coal, because there were no consumers within the large scale. And this caused also, on one hand, the accumulation of coal, but it caused, in this time, also the appearance of ice, the situation of an ice age, because of the reduction of CO2 in the atmosphere, as we know. The next step was the development of large herbivores, because they found a huge vegetation and there were no big competitors, so they could develop a large scale, and it was followed by a second system with also large herbivores, but with an additional intensification of information interaction. To give you an understanding of what this means, the bees know still today how this works. Bees are producing honey from wood lices, which are functional at the system which we had at the time of dinosaurs. They're sucking sap from trees anywhere on the tree, and the bees are using this excrete of them to produce honey. But if they operate in a modern system of the flower plants, so are directed and guided by the plants to pick up the nectar from the flower and hold in exchange the pollen transfer and the pollination of plants. So the second one is information, much more information influence than the first one. This had also an influence on the development of the brain-body relationship. If you look at the brain-body relationship of dinosaurs, they have smaller brains in relation to the body, but were still successful over approximately 150 million years. And the development of brains and mammals was also influenced by the need to operate and process much more information. So, which lessons we can learn from this progress? Biological processes can modify but not overcome abiotic processes by selective use and autonomous storage of energy. The ubiquitous regulators of ecological processes and also interaction processes are microorganisms. But we cannot see it because they're too small, but they are everywhere existing. Top consumers involved in a network of organisms with similar capabilities. Mental capabilities can block the evolution of potential competitors with high mental capacities. For example, dinosaurs and mammals evolved at the same time, but the dinosaurs occupied the ecosystem for approximately 150 million years, and mammals had a few chances, only conditions to exist there, and this big extinction event opened the door for mammals to evolve in a huge dimension. And there's always the question, what is a successful evolution behavior? Successful from the perspective of long-term evolution as scavengers. They did evolve, example, bacteria, fungi, mice, earthworm, and millipedes. There's also a theoretical explanation why this is so. If you remember the pictures we have presented before, heterotivores existed at the beginning of the evolution of ecosystem on land. So, what can we use as a model? not in the sense of to model it, maybe we cannot model it, but as an example, because ecosystem are self-organization processes which are directed away from thermodynamic equilibrium. It's an uphill process. So the order is dependent on the availability of energy, which should or is a long-term available energy source. On one hand, we have the chemotrophic with some interruptions, but the successful, which we know, was the energy source of the sun. Integration in the system is governed by the rules of balanced flows of energy and recycling of material, because on the particular land ecosystem, you have always the situation that material will erode. It's the risk that it will be lost, so it is important to recycle material inside. Spatial structures are designed to fulfill multiple tasks. If you look at the forest, you look at plants, if you look at different life forms, you could learn how far the forms are adapted to dissipate energy or to adapt to a particular situation. And the unexpected disturbances which are common in the evolution are compensated by redundancy, but not only redundancy in number and so on, it's redundancy of different local populations, with a spatial heterogeneous redundancy. So, there we have to be careful to use evolution as a model. We have to be careful in the selection of energy sources beyond food, because it should be focused on long-term energy flows on the one hand, is correct, but on the other hand, it should be complementary to biological energy sources, because otherwise we will disturb or also destroy our biological basis of our life. But there's also a big risk, which you can meet in several discussions, that biological processes are used as arguments for some decision, but normally they are used to undermine human ethic rules. We have several examples in history, and we still have it, where such mistakes were made. And we have also be careful in transformation of land use practices to regions with different framework conditions. For example, the transformation of land use practices, which is developed in Europe, cannot be applied in tropical soil, because we have quite different situations, and we have to be very careful to adapt to the situation. I showed you the continuous flow of energy. This is quite different. We have to have consideration, we have to learn it. These are some paradigms where existing and very prominent. Okay, what are the common and peculiarities of humans? Humans, on one hand, deeply rooted in physical, chemical, and also biological roots, but they have the peculiarity of macro-community, which is an emergent property which exists only in human society at this scale. If we look over evolution time, of the human evolution time, we are very short now. In the geological time, there are only 2 million years. We have the human evolution is accompanied by stone artifacts, and also approximately 800,000 years ago by the ability to use fire. And the next very strong impulse came during the last thousands of years with the development of agriculture, and at the end of the 19th century, or before the processing of iron was also important, we have the development of the use of fossil fuels, but it's not only the factor because of the use of hygienic, we have the use of industrial production of nitrogen, which caused this high impulse of these changes which we're observing now. And to look a little bit at the systemic interaction, in the original situation, humans were regulated by biotic availability of food, and were also regulated by pests and so on. The first step of artifacts reduced a little bit the influence of biotic systems, and with the development of agriculture and our technosphere, the situation changed heavily. On one hand, we used the technosphere, or we used fossil fuels to provide the technosphere we're discussing now. Agriculture was a strong competitor to a biological system, but it had a input on population growth, and the hygienic change that influence heavily of microorganisms which run in the normal system. So, this is what was very interesting, because we're discussing about evolution of human, but if you look at the human evolution time, you will find not heavy changes of the human physiology. You have only dominantly the growth of the brain, but we have no wings, we have no flaps and so on, because we remain physiologically more or less the same as some billions ago. And also, a lot of our social habits remained in this state. We have still the inherent preference for direct growth. This means the growth of populations, or transformed growth is the accommodation of goods and material. Because it was successful in evolution, because environmental regulators were very important, and if people didn't grow, so they would die out. We have also a high attraction by strong energy sources, which can also explain by evolutionary aspects. We have also the strong tendency to avoid physiological losses of exercise. If you have, for example, try to realize if you have a very few food, so it is necessary to rest the time where you don't have to move and to expand your energy at the time that is necessary. This is important. And we have also the preference of unidirectional flow of materials to human societies, because in ecosystem there was no need to recycle material, biological material. It's different what was mentioned for the land or with the iron material, where there was no recycling, but normally we have to use. You can also look on the street where people are throwing away if they eat anything. And our capacities for social adaptation are restricted. I'm speaking of societies, are restricted to direct feedback loops, where you can see, okay, this is a real negative feedback. People will accept changes, but if there is no observation of such influences as an effect, then there's a high problem to explain people how to change the habit. But we have also, on the other hand, high capacities to operate in complex social conditions. So, is the question, are we simply modified, or our social paradigm modified by our artifacts and the ability of energy, or in much more a higher extent also by our virtual world, where you can present everything as reality, but it will not work in reality. It will only work in the computer. To show a difference between our ability to manage with complex local situation, I should give the example of the burning Austrian Alps problems, because there was a high discussion between here and Austria about the true dimension of Alp areas, where the animals and some on the Alps, and they had some potential severe economic consequences for farmers. Semi-natural alpine networks are fractal, because dynamic fractal, they will change all the time. You have no scale where you can define a precise boundary. So look at the Alps situation. Some of these plants can be used by animals, others cannot be used. And if you go down the scale to some few millimeters, you will also find some boundaries and so on. And the next point is that they are faster in the function, because in Alpine areas you have not only husbandry animals, cattle and so on, you have also wild animals, but you have also the situation that animals are going for grazing in the forest, but on the other hand you have areas where there is no vegetation, but they are important for animals to survive hot periods. It was last summer in the Alps, but it was very hot, but the sheep used this snow spaces to cool down, and you have also the situation that Forests is on one hand forest, on the other hand also used for animals, in this case also natural protection area. So the peculiarities of such conditions are considered in the traditional use rules of farmers, because there's an agreement, okay, in this way we will use an area, but the approach to use an objective information, technical land cover survey methods, for example remote sensing, it will not work very well, because these instruments are very well adapted for areas where we have land use with clear boundaries and with one simple land use. Because with remote sensing you cannot find the land use, you will find the land cover. The difference is land cover is forest. Independently what is done in the forest, but if you have the forest also for grazing, there's no information in the land cover. The problem is that you will need a high amount of money to go down to have a better resolution. This problem is behind the, or these facts are behind the problem of the discussion of the IM areas. So, now what are the main barriers to change the human habit? One of the biggest successes, or the biggest barrier is the success of evolutionary misdirected behavior within human competition. Because if you have a full bucket, it is easy to put something out and you will successful in comparison to a competitor. People don't like unpredictabilities and uncertainties in environment and social processes. Each person which can explain the future in a smooth way is welcome, other which we discussed about risk are not welcome. We have also problems with existing dogmas and paradigms. And we have also the problem that humans don't like to accept human characteristics and their influence on social solution capacities. And on the other hand, we have the effectiveness of technological solutions for compensation of required social solutions. We compensate this everything that will be the next technical solution. And the future will depend on the awareness that solutions for human societies cannot be provided by technology, but on social efforts to adapt organizational and technological conditions to human mental capacities under harmonized consideration of local peculiarities and commons at larger scale. There is a technical term in the European Union, subsidiarity, which is written on some paper but is not realized in practice. And to imagine which potential we have, because we have the potential to influence over our individual life, the time we have normally not large influence in the area, but if you cooperate with other ones, we can extend the area of our influence. And if you look at the political space, they have a relatively short lifetime, because in a democratic system they can only operate over short time, but they have a huge influence over time. And an open question is how the responsibility of global enterprises which can survive over decades